Okay, so we'll be doing kind of working through some of those review problems from the midterm practice exam I posted. But I also wanted to mention some details about the exam. So it's going to be 10 multiple choice worth 40 points. And then it's going to be 5 kind of short answer questions that are worth a total of 60, right? So those short answer questions are going to carry a little bit more weight. Each one of those short answer questions has like a file. You can upload a file. So it's going to be like however you would do your work for a homework assignment, kind of upload it however you're doing that, right? So a lot of you are just kind of taking pictures. You could save if you have some things that you want to type out instead of write out by hand. You could upload some Word documents. Really, however you find it easiest, but probably the same kind of method you've been using for turning in your homeworks, right? If, there's 5 different questions and they each have an upload, if it's easier for you, like however you're doing it, to upload it like as one file, right? Like one big document or one big PDF or something, that's okay. You can just upload that once. I'll be able to see it. If you do it that way, just upload it to the very first short answer question. That way I can see that you've worked through all of them in that one file. Or you can submit each one individually, right? Your work for short answer question 1 to short answer question 1, then upload, pictures or however you're kind of recording your work for short answer question 2. Either way is fine there, as long as all the work is somewhere there uploaded on the exam, okay? Once you start, you'll have basically an hour and 20 minutes, or an hour and 20 minutes, 120 minutes or 2 hours to complete it. So it should be more than enough time. I really was gonna do about, 90 minutes, but kind of gave the extra 30 minutes so that you're not rushing and that it's easy to kind of upload those responses to the short answer without having to worry about kind of time towards the end of the exam, okay? If I were studying, the way I would do it is kind of go through those midterm practice problems, look at the answers to that, start reviewing homework 1 and the answer key that's up there on Canvas. As soon as today's over, your second homework assignment is due at the end of the day today. So tomorrow, first thing in the morning, kind of what you'll see is posted is the answer key to the second homework as well. So that'd be a good thing to review. I'll have the exam show up tomorrow at 9 a.m., right? So it'll be available tomorrow at 9 a.m. And what I decided was, I would prefer that you probably take it Thursday later in the day or on Friday. But because I know schedules are kind of tough, because I still want to be able to kind of review some stuff with you in Thursday's class, right? So we just want to keep going over kind of some review problems or go back over old homework problems. We can do that on Thursday. I'll basically show up here and basically taking questions from you guys and then kind of working through things that you want to see as kind of like a final review. And then I'll be posting that as well on YouTube as a kind of a recorded video. So I realized that if you wanted to watch that, it gives you a little bit less time to kind of prepare for this exam. So I'm actually going to have the exam open until all the way to the end of the day on Sunday. So if you do want to take it this weekend, depending what your schedule looks like, you can log on anytime after tomorrow morning at 9 all the way to the end of the day Sunday. Once you log on and start that exam, though, you'll have 2 hours to submit it, okay? It is kind of open note, I guess, an open book. So I would suggest maybe having whatever notes you take there kind of with you. It might be a little bit, it's going to look similar to kind of the homeworks in terms of the short answer questions, kind of that level of difficulty. The multiple choice may be a little bit easier than kind of what we've seen on the homework, but the short answer is going to be difficult. And that's because I know you kind of have your notes and things available to you. Okay. Any other questions from me before we kind of start doing a little bit of review today? Okay. All right. So let's start out. I want to make sure I go through ones that I think are probably most important after writing the exam. So we'll start with problem 1, thinking about kind of what some of these multiple choice questions could look like. So assume we have 2 teams currently revenue maximizing as monopolists, right? Or, even if we want to think about this as profit maximizing, we'll end up saying that doesn't really matter because our costs here, when we're thinking about a ticket market, right, runs along the x-axis. But either way, so team A is currently selling a number of tickets below its capacity, and team B is currently selling tickets equal to its capacity. If both increase the size of the stadium, which of the following is going to occur? Okay? And so we have things that, revenues are going to go up or down or remain unchanged. We have things about price changes for team B. But let's just think through the entire scenario, okay? And I already forgot. Was it team A that was that? So team A is below capacity. Team B is selling equal to its capacity. Oh, wrong video. Switch over here. Maybe. There we go. So we're thinking about a ticket market. So we've got the quantity of tickets down here on the x-axis, my price up here on the y-axis, right? Let's just first start out drawing in capacity, right? It's going to be somewhere. So basically, this is our marginal cost or our supply curve, where it runs along the x-axis up to the point of capacity, because the marginal cost of each seat is 0 once we've already paid to have those kind of seats there. So for team B, they were selling below capacity, and I think we were told they were monopolists. So let's assume that, I don't know, looks something like this. So we'll say the demand for team A, their marginal revenue, hit down here. So the equilibrium quantity for team A was kind of below capacity. And kind of think about, here's the price for team A. Okay. What was the change that then occurred? They both increased the size of their stadium. Okay, so for team B, if they increase their capacity, what's going to change? So, or sorry, team B. Team A, if they change their capacity, what's going to happen? So capacity increases, all right? We can kind of think about this as capacity, the second capacity we're looking at. What's going to change for team A? Absolutely nothing, right? Marginal cost still hits marginal revenue down here. Price will stay the same. Everything for team A is going to remain the same. Same quantity, same price, same total revenue. Right? But what if we had team B, who we were told was selling out or selling to capacity, so their marginal revenue, team B, is hitting capacity somewhere like this. That way the quantity is going to be whatever capacity is, the equilibrium quantity. Equilibrium price would be somewhere up here. Well, at the new capacity, right, if I'm kind of continuing this, now the equilibrium quantity, right, is somewhere down here. So equilibrium quantity is increased, but equilibrium price has decreased. Right? So we see an increase in quantity, but a decrease in price for team B, which means what has happened to total revenue? Quantity's gone up, but price went down. What can we say about total revenue? We don't know, right? Could go up or down. Depends on how much each one of these changed. So essentially, kind of it depends, right? Or we're not sure, right? It depends on the kind of the size or change in price and quantity. Really what's going to depend on is kind of the elasticity of our demand curve, right? But basically, we know that price is going to go down, tickets sold is going to go up. So let's look at these possible options. So for team A, we said nothing changes. So this one actually becomes pretty easy because revenues, if we're thinking about the revenues of team A, well, there was no change in their price and their quantity, so their revenue stayed the same, right? So right away, we know B has to be the right answer. Well, let's just assume that one of these other ones also said that revenues for team A would remain unchanged. For team B, we said we saw price decreases, and so that would be kind of the second part of that. Right? Or it could have potentially been, right, we see an increase in the quantity of tickets if we increase that capacity. For team B, not for team A. Okay. So knowing how to draw that ticket market, knowing how to, see if I can get this a little bit bigger for us here. Knowing how to draw the demand and marginal revenue for a team that's not selling to capacity versus a team that is selling out, right? That's kind of an important thing to know going into this exam, okay? And, instead of a capacity increase, I could do a capacity decrease, but as long as you kind of start out drawing it correctly, you'll be able to kind of determine what those effects are, okay? Any questions on this one before we kind of keep moving here? Let me pull the chat up so I can always see in there. Okay with this? All right, so understanding the ticket market being under and above capacity. This one's not as important for us. I'm going to try to focus on the ones I know are the most important. So if we have teams that are small and large market, and we're thinking about profit and win maximizing, right? So what situation would lead to kind of equal revenue, which situation would equal revenue sharing, improve competitive balance? So if we have this revenue sharing where we're taking the same percent from every team and then giving it all back equally to the league, which one of these scenarios would that revenue sharing improve competitive balance for the most, right? So we're thinking about different combinations of win and profit maximizing. So let's think about the market that we're looking at here. So whenever we're talking about revenue sharing, we should be thinking about, we're taking a look at the win market, right? And kind of looking at how that impacts competitive balance. So got our number of wins here, kind of dollars as our units on the y-axis. We're going to simplify using kind of a constant marginal cost. So a lot of times in examples like this on the exam, I'll make sure I explicitly say, you can assume kind of a constant marginal cost here to simplify. So we've got a kind of small market team. And then we've got our large market team. Right? Okay. So when we use revenue sharing, right, it's going to shift each one of these curves backwards, right? Because I'm no longer keeping 100% of the revenue from something. I'm only keeping, maybe 50%. So we talked about in all these scenarios, it should help improve competitive balance in the sense that that large market shift, if it's the same percent, right, it's going to be 50% of a larger value. We're going to see a larger shift in the large market than we will for the small market. So just before we even think about win or profit maximizing, just using revenue sharing should help improve competitive balance. However, there's going to be one scenario where after those shifts, so I haven't drawn those, like think about this as like after the shifts, right? Because in every scenario, they're going to shift the same amount. Okay? So in which scenario would revenue sharing help the most though, right? So it would help no matter what the teams are doing, but which would it help the most? So once we have revenue sharing, we can think about each team is going to face kind of their own average total revenue curves, which we know are going to be a little bit further out in the demand curve. So if they were both profit maximizing, right, after the shifts to their demand curve, what does the revenue sharing do to change competitive balance? Well, they both still keep profit maximizing where marginal cost is equal to marginal revenue. And so we can kind of think about if they're both profit maximizing, whoops, large market, that's a pretty big gap still. Right? Now, what if the small market team is win maximizing and the large market team is win maximizing? Okay. Well, if they're win maximizing after the shifts to their demand curve, if they're win maximizing before, profits were equal to 0 where the demand curve hit this constant marginal cost. Right? Now, profits aren't equal to 0 until we get out to this point where the average total revenue curve is equal to the marginal cost. Sorry on Zoom if you guys are hearing those cars. Okay, so you kind of think about here, I mean, it's kind of hard to say whether or not that gap is any bigger or any smaller than the gap between the profit maximizing points, right? Because they're both still going to be able to push out to that average total revenue curve. So if I'm thinking about, these are all the possible points I could see, right? My profit maximizing points, my win maximizing points. I say points, number of wins, right? So which one would competitive balance help kind of cause the smallest gap in the wins, right? Or improve, how would revenue sharing help improve competitive balance the most, or make that kind of difference in wins as small as possible? Well, we can see the locations where these would be as close as possible, right? But when I have a small market team win maximizing, I have the large market team profit maximizes, because then the large market team doesn't push out to where profits are zero. They just pocket all the money given to them from the league. And the win maximizing teams, who are small markets, just spend all the additional money they're getting from the league to kind of improve their quality and obtain a higher number of targeted wins. So the situation in which revenue sharing helps kind of reduce competitive balance the most is a small market team win maximizing and a large market team profit maximizing. Now that question is probably a little harder than maybe one I would ask on the exam, but you do want to understand kind of where all these points are at when we're talking about large versus small market teams, and kind of how this revenue sharing adds in this average total revenue curve. Any questions on that? I know it's a little bit, it's kind of a lot in one there. I answered more than just that one question, but I wanted to make sure we kind of understood all parts of this type of a market.
Why is the average total revenue in a large market greater than
Greater than the profit?
I mean,
oh.
I would expect for them to lose money off of profit.
Yeah, so I said we will originally see a shift in these demand curves. So the original demand curve before revenue sharing for large market teams was like somewhere out here, right? But because we know we'll see those same shifts no matter what the teams are doing, the demand curves are still going to see the same shift. We didn't really have to draw out that shift. But you're right. Their old demand curve was probably somewhere out here where it was higher than average total revenue, because they're going to pay in more than they receive. But, after that shift occurs, they still can make decisions based off of the average total revenue, because they're getting this lump sum back from the league, which, yes, it's less than what they paid in, but it's still kind of not attached to any number of wins. That was a good question, though. Any other questions on that one? All right. Skip this one. Skip this one. Okay, let's think about kind of this one right here. We haven't looked at a ton of these models. So suppose we have kind of NASCAR drivers going head to head. If last year the first prize was $1 million and the second place prize was $500,000, suppose now that we've got first place prize of $2 million and a second place prize of $1.5 million, what do we expect to happen to effort levels of these drivers going head to head, right? So what I want to point out here is when we're drawing these models for effort choice, we're thinking about effort is the thing being chosen. Kind of think about here, we can think about this as price or just kind of units of dollars on our y-axis. We're going to have these increasing marginal cost to effort, right? And we even talked about like quality differences between players that, putting in the same level of effort is more costly if I'm a lower quality player. So you can think about kind of, we would see this reduction in the supply or kind of marginal cost of effort if we had a lower quality player. And that was just one thing that we reviewed, but doesn't necessarily play a role in this question, but just goes along with this topic. So the marginal revenue curve that we were thinking about in these winner-take-all tournaments, or these head-to-head tournaments, was basically a straight line, right? If I put in this amount of effort, the marginal revenue I get is essentially the additional revenue from going from first to second place. So it's just going to be the difference in the first prize and the second prize, right? That's the point where we would graph that marginal revenue curve. Well, I think in both scenarios, right, it was 1 million and then $500,000 and then 2 million and $1.5 million. So in both scenarios, the difference was $500,000 between that first and second prize, right? That was the additional revenue generated if I win the tournament, right? So what's happened to the optimal level of effort from both players? Hasn't changed at all, because that prize gap is still the same. Now, if in the second year, let's say instead of 2 million and 1.5 million being the prizes, it was, you know, I don't know, 4 million and 1.5 million. Well, then we would have this marginal revenue curve way up here, right? Where the difference between 4 and 1.5 million is 2.5 million. So there's just a higher marginal revenue that we're facing. You know, I didn't even draw it far enough here, but right, the optimal level of effort now is going to be much, much higher. Right? So really that marginal revenue curve is based off the difference between that first and second place prize when we're looking at these winner-take-all tournaments. Okay. Any questions on that one? But in this scenario we were given, the difference in the prizes was the same, so we saw no change in the optimal level of effort. Right? So remain the same would be our answer. Okay? Any questions on that one? Okay with that? I think I want to work through, we'll do 7 then 8. So let's say we've got some positive externalities that exist that are greater than the negative externalities. What's going to be true about the current number of games that the team decides to play relative to that socially optimal number of games? So we touched on this I think it was last week or maybe the end of the week before. We started talking about positive and negative externalities. Okay. So here we're told, I think it was that the positive externalities are larger. Okay. So if we have positive and negative externalities existing simultaneously, I personally think it's easier to draw them out both individually and then think about what the total effects will be. So if I want to think about kind of here's my quantity or my number of games that were being played, and there was some marginal cost to providing those games or the supply curve, and there was also kind of our demand curve or the private kind of marginal benefits. So with no like influence at all, the market arrives at this kind of equilibrium price per game, if you want to think about it that way, but also this equilibrium quantity of games, right? If you want to kind of write it as G star, right? If you wanted to, we could use that notation as well. It's the number of games here, the equilibrium number of games. Okay? So if you wanted to, you could think about instead of Q as the quantity of games being played, just kind of G as the number of games being played. So if we have a negative externality, right? That means that we have some additional costs. So at every game played, right, the very first game being played, there's an additional cost. Next game played, some additional cost, right? So we end up, it's almost like with this marginal social cost curve, which is really the marginal cost plus the externality. Or we can think about this very similar to taxes, right? Taxes are an additional cost. Externalities are an additional cost, so it shifts that supply curve to the left, or kind of decreases my supply there. I'm willing to supply fewer games at every single given price. So now I look and say, okay, what would society, I guess we can call this society's equilibrium here. So if we have a negative externality, right, we're playing too few of games. Right? The number of, if we have a negative externality, the number of games being played is higher than what is socially optimal, right? We would like there to be fewer games played for society, right? The market arrives, the market doesn't take into consideration externalities at all. Somebody else is bearing that cost, right? So the number of games being played is kind of too high. So with a negative externality, we've got the number of games here. It's too high, right? So that's the first impact. So the second thing that we want to draw out is kind of, well, what if there was a positive externality? So let's just draw that out separately, and we can think about what happens when we have the combination of the two. So go through this again pretty quick. We've got, here, I'll write this as G here, number of games. Here was our equilibrium point without any externalities. If we have additional benefits, right, so now we've got this positive externality. That means for every game played, there's an additional benefit to somebody else. So every game played, there's an additional benefit, right? We end up with a marginal social benefit curve, which is the private marginal benefit plus this positive externality, right? So society would want the number of games to be played to be somewhere out here. So with a positive externality, the number of games being played is also, sorry, not also, it's actually the opposite, right? We have that the number of games being played is too low. Okay. So we have a problem, right? Because the positive externality says the current number of games is too low, but a negative externality existing means the number of games being played is actually too high. Right? So if we were to overlay these two things on top of each other and think about where kind of the marginal social cost and marginal social benefit curve would intersect, well, it depends on which of those is larger. Okay, so if we go back to the problem, it says the positive externalities that exist are greater. Right? So what that means is the effects of this positive externality are going to win out against the effects of the negative externality, right? They kind of cause that marginal social benefit curve to shift out more than we see the marginal social cost curve kind of shift to the left. You can almost think about it as here. Once I drew this out on here one time, the first time for the negative externalities, if I'm then told, okay, you have a positive externality that is the exact same size, what that would mean is I have my positive externalities. I'm going to see if I can get this, make sure I get this drawn correctly. All right? So here's my marginal social benefit curve now. And now the new equilibrium would be if they were the exact same size, then we would actually be playing the perfect number of games, right? But if that shift in my marginal social benefit curve, right, or that positive externality is larger than the negative externality, then I'd be somewhere maybe out here, right? A much larger shift, and now the externality, or the equilibrium would be somewhere out here. Now we can see the number of games being played is much too low, right? And so that was the effect that won out, was the positive externality. The positive externalities effect won out if we were to kind of draw that as a much larger positive externality than existed in negative externality. Okay. Any questions on that one? I know it was a little bit tricky. It's kind of like when we have supply and demand changes, right? It's usually easier to understand the effects of each individual change and then kind of think about, okay, now I need to know which one of these is larger. If they're moving in opposite directions, whichever one is larger, well, that's the effect that's going to win out. Same kind of idea here. We really are just seeing supply and demand shifts. It's just that those shifts aren't really shifts in the supply and demand curve. They're where the social kind of cost and social benefit curves will be. Well, I think we went through one like this on Thursday, but it's probably a really good thing to know how to work through a problem like this. Wink, wink, since I wrote the exam. So we're going to work through another one like this and try to get some more practice. So let's say I've got this consumer, the individual kind of representative consumer has a demand curve that's equal to 150 minus 25Q. Answer the following question. So what's the highest price a consumer is willing to pay kind of for a single ticket, right? If this is the representative consumer, what's the price they'd be willing to pay for that first ticket? Yeah, so if we have the demand curve, really what this price or this y-axis point is telling us, because remember, when we graph this, quantity and price, this is really just going to be some line, right? And so the price or the y-axis point is really just telling us this is how much someone would be willing to pay for that unit. So that must be, you know, they'd be willing to pay up to that price or up to exactly what their marginal benefit was. So we can think of the demand curve as really telling us the marginal benefit of each one of these units. So if we can only buy tickets in kind of integers, right? I can't buy half a ticket. What would I be willing to pay for that first ticket? Well, the amount that I'd be willing to pay would be up to kind of that marginal benefit. So I plug in 1 here. I get 150 minus 25, or the price for that first ticket the consumer would be willing to pay is $125. Now, here's where it's a little bit weird, and I would say you could represent it differently, but I don't want to use as complicated of a model as we would need. But it's easy to think about, even though I can only purchase 1 ticket, it's not just that this was exactly my margin. That was the marginal benefit of getting that first ticket. It's almost like the surplus that could exist would be the entire area under that curve, right? Because there was some marginal benefit that might have already been diminishing, even though I couldn't buy half a ticket. Like if I could attend half of a game or something, maybe I'd be willing to pay a little bit more for that than, you know, the whole game. And so they still have this kind of linear demand curve. So even though the marginal benefit for that very first ticket, right, because we have to make it kind of discrete, is $125, we can still think about as the surplus is the area that's under my marginal benefit or under my demand curve up to whatever quantity of tickets I purchase. Okay. So the next question there was, if a team wants to set a quantity discount, what should the price of the second ticket be and how much additional revenue is generated? Well, the additional revenue isn't that hard. You know, if instead I wanted to say, okay, for the second, you know, we'll charge $125 a ticket because we know people are willing to pay that, right, to buy their first ticket. And then and maybe this is like over a season. And then we say, well, if you buy a second ticket for, you know, a different game during the season, we know that your demand curve is decreasing. So we're going to have to, in order to get you to buy that second ticket, it'd have to be a lower price, right? And so what is that price going to be? It's as simple as what we were doing before. It's just now we plug in a 2 into quantity, right? So if we plug a 2 into here, get the marginal benefit. That second ticket is $100. So we set the price at $100 and the additional revenue we gain. But we're only getting that kind of additional $100 as the team from selling that extra ticket. So the additional revenue is just whatever the price of that second ticket we're charging using this quantity discounting. Sounds probably a little bit, might have been able to overthink that one a little bit. We're really just looking for the prices of these different quantities of tickets by plugging in that quantity to our demand curve. Okay. Now I think C here is probably, what if they were a single price monopolist, how much revenue? You know, I think it doesn't ask for all this, but we could go through the entire thing and say, okay, what price will they charge? What quantity of tickets will they sell? And then what will the total revenue be? So it's kind of weird when we build these models based off of a single representative consumer, right? So I've got that demand equation, which is 150 minus 25Q. So I know that my demand curve is going to start up here at 150, right? When the quantity is 0. When the quantity is 0, 0 times anything is 0, so the price would be 150. And then I want to figure out, okay, so here's my demand curve. What point does it hit my x-axis? Well, we've got quantity of tickets down here. I'm going to rewrite my demand equation here so I don't have to keep moving the paper. What I'm really thinking about is, at what quantity would the price the person be willing to pay be 0, right? So I set price equal to 0, and now it's just I need to solve for what that quantity is, right? So I do a little bit of algebra here, and I get quantity is equal to 150 over 25, or what? 6? Now I think in this equation we're told, well, it's a single price monopolist, so we also need to know, okay, where does that marginal revenue curve intersect the x-axis? Because if I'm looking at tickets, the marginal cost of providing additional seats is 0, All right, there could be some capacity, but with any one individual consumer, I'm not going to hit that. Okay. So where would this marginal revenue curve intersect my x-axis? Well, the marginal revenue curve is the same as the demand curve, but it's twice as steep, right? So my marginal revenue curve is 150 minus 25 times 2, or 50Q. I could then do a little bit of algebra here and find the quantity where marginal revenue is equal to 0, right? Where it hits that x-axis is actually what, 150 over 50, or 3. And in all these linear, I just dropped my mouse. In all these linear demand problems, right? And I'm always keeping linear demand, or demand to linear in these examples. The point where the marginal revenue curve hits the x-axis will always be half of whatever the demand curve hits the x-axis at, right? Just by the byproduct of having it be linear, and that the marginal revenue curve is twice as steep if we're dealing with a linear demand curve. Okay? So we now know that the quantity that the monopolist will choose is 3. What price do they charge for each ticket if they can only charge a single price? It's going to be the point that we're up at on the demand curve. So how do I find the price for this point on the demand curve? Well, just plugging in that quantity to my demand equation. Right? So I'll plug in this quantity into my demand equation, 150 minus 25 times 3, right? Which gives me what? 75. Okay. So how much total revenue is generated from this consumer? Well, I'm selling them 3 tickets for $75, right? So total revenue is just price times quantity, or 3 times 75. So I get what? I'm kind of running out of room here, but I'm going to cheat. I'm writing this old one. So I'd get what? Total revenue is 225. Any questions on any of that? Move this guy out of the way. Okay with that? And then I could do things like, well, what's deadweight loss here? Well, if this wasn't a monopolist, what number of tickets would they sell to this consumer? They go all the way out to the point where the demand intersects that marginal cost or that supply curve. So really, by having a monopolist, we're losing out on this surplus. Any other questions? All right, I think the next one is then, well, what if you were going to sell them a block of tickets? What would the fixed fee be? And this is where we said the optimal number of tickets would just be wherever that demand curve intersects the x-axis, right? Anywhere where that ticket would have some type of surplus associated with it to the consumer, I want to go all the way out to that point on the demand curve. So I would optimally want to sell a block of 6 tickets. And then the amount that I could charge, right, would just be the area under that demand curve. And if I keep the variable cost, once they purchase like this block of 6 tickets, there's no additional fees. So the marginal cost is 0. So essentially the price they pay per game would be 0. So the entire area under the demand curve, right, if I were to shade all this green, that would represent the amount of money I could charge that person up to that amount, and they'd still be willing to pay it, because this would be the value of their surplus or their benefit, right, from all 6 tickets. So if I had a scenario like this, that's really just finding the area of a triangle, right? So let me give myself a little room here. So all we'll be doing is what? 150 times 6 times 1/2. So what? $450 if I'm doing math in my head correct here. So by charging a fixed fee of $450, I could sell all 6 of those tickets, relative to setting a single price per ticket where I was only generating, oh, it's down here, $225. Okay. Any questions on that? All right. Yep, yeah, relative to Part C, which is we only had kind of $225 per consumer. Yep. So yeah, the difference between the two would be the additional revenue. Yep. All right. I'll save this one. So number 10. So how would you argue that free agency had no effect on competitive balance in baseball, despite the rich teams being able to buy the best players, assuming that transaction costs to trade are relatively low? So this is more of a discussion. I'll go over how we can think about this problem. I probably don't have as many as kind of open-ended like this on the exam, but it has a principle that shows up on the exam I want to talk about. So, oh geez, I'm for a lot already. So if we're thinking about free agency, right? Before that, that was a scenario where we had the reserve clause where, you know, a team was the only team that could make a deal with you, or they could trade the rights to you, right? So why would getting rid of that really have no effect on competitive balance, right? So this is kind of revolves around the invariance principle. So this was the idea where we said, whoever values a resource the most, in this case, whoever values a player the most, no matter who starts out with the rights to that resource or that player, the person who values the most, or the team that values the most, will be willing to pay the most, right? Now, they may not be paying the player, right? They may be giving money to a different team to obtain the rights to that player, but it doesn't matter whether or not they're the only ones that have rights to re-sign the player, or they can trade them, because they'll trade them to whoever values them the most. So that was kind of the invariance principle. Whoever values something the most is going to be the one who ends up owning that thing, or owning that player in this case, right? Having a deal with that player. So the only time we said this breaks down is if we have transaction costs that get too high, because, you know, then potentially the team that values it a little bit more, well, even though they might value that player, I don't know, $5 million more than another team, if the transaction cost to trading and obtaining that player is something like $10 million, maybe because of luxury tax issues, then that trade won't happen. And then the player doesn't end up on the team that values them the most. But if we don't have any transaction costs, that invariance principle should hold. We talked about it with draft picks. Why doesn't it matter kind of who gets what pick in the draft? Well, in any given year, whatever team values that top pick the most, that'll end up being the team who gets it, right? Because even if they don't have the rights to it, they'll find a way to trade for it if they, you know, really do value it the most. Okay. So kind of reviewing that invariance principle, and kind of the discussion we had in class might be a good idea kind of going into the exam. Really, number 13. So this is kind of same sort of topic, so we'll kind of go to that one. It's talking about what happened to wages once the reserve clause was lifted. Use a graph to show why potentially. So really, the reserve clause was really just teams kind of making sure that they maintain monopsony power. Because if I'm the only one that can sign a deal with you, or I you know, if I want to, I can trade you, well, I'm the only consumer of your labor, right? So that makes me a monopsonist of your labor. So what did a monopsonist do? And here we're thinking about kind of the quantity of labor. So the price of labor is, you know, the wage. Right? So we have some demand curve for labor and some supply curve for labor, right? And we said, you know, without a monopsonist, kind of works just like the product market. We get this equilibrium wage and this equilibrium quantity of labor. With a monopsonist, they make decisions and they set the wage based off of this marginal expenditure curve. So it's very similar where a monopolist kind of sets that price, and we can kind of go through the, you know, multiply price times quantity, plug in the demand curve, take a derivative to figure out that kind of where we're setting the optimal quantity and price will be based off of twice as steep marginal revenue curve. The same idea would apply to a monopsonist, right? What are their total expenditures? I guess we can kind of go through this real quick to maybe give a slightly better understanding. So total expenditures would be what? Kind of the marginal costs times kind of the quantity. But marginal costs vary depending on the quantity. But remember, the supply curve, right? We would have some equation for the supply curve, or maybe it was like, I don't know, something like this. We could think of the supply curve really represents marginal costs, right? So I've got my total expenditures would be something like 10 plus 20 Q times Q, right? And then think about how can I maximize this equation? Well, that's where I take a derivative in respect to the thing that I can choose, so the quantity of labor. So if I take a derivative in respect to Q here, I would get 10 plus 2 times 20 Q. Or essentially, if I think about these instead of actual values, just A and B, my marginal expenditure, right? Once I took a derivative of the total expenditure, that's marginal expenditure, is the exact same thing as my supply curve, but twice as steep. Right? It's the same sort of idea. And I'm not going to make you like walk through and ever prove that in the exam or something. I'm just kind of giving you a little bit more insight as to where that comes from. Okay? So we'll have this twice as steep marginal expenditure curve. We'll choose kind of the quantity where it intersects the demand curve. So I'll call this the quantity of the kind of monopsonist here, right? But then they don't pay a high wage, right? They're the only person who can make a deal with this player, so they're able to pay that player a wage that they know this is as low as I can go, and the player would still play for that wage. So with monopsony power, we get this kind of lower wage and a kind of lower number of labor units, right? Labor hours or number of players. We said it's going to be some type of, doesn't matter how we're thinking about, some type of labor units there. Okay. And, you know, we could think about things like, you know, here's our deadweight loss, right? But really just understanding kind of the basic effects of monopsony power there. And really that's what the reserve clause was, right? Was monopsony power. Okay. Any other questions on that? Before I keep moving. Okay. Oh, what's another one I could add some stuff to that we might not think about? Is there any multiple choice ones that we skipped that I think would be good? We did the equal revenue sharing. We did. So I'll do. I guess I'll do the game. I kind of want to say that for Thursday, but it's taken aside from some of these. Because one thing that's not in those, one thing that doesn't show up in those midterm problems is some stuff we talked about towards the end, which would be thinking about salary caps and salary minimums. So I think this is kind of difficult to think about, but if I have, let's just think about one team here. So let's say we're thinking about instituting a salary cap. Right? So we want to limit the amount of money that a team can spend. So let's assume that both teams have the same marginal cost curves just to make it easy. Right? And then let's say we've got a small market team with the demand and marginal revenue curve here. And let's think of a weird scenario. So a lot of the times I draw these, I draw them very far apart to really accentuate kind of the difference between large and small markets. But it could be that it does look instead something like this, right? Where the difference in the demand curves and the marginal revenue curves isn't near as large. So if this is the scenario, let's think about if I have both of these teams profit maximizing, right, I'd be at these 2 points. If I wanted to use a salary cap here, how could I do so effectively? Well, each one of these number of wins, I could put a number to it. You know, I don't know, maybe this is 40 and maybe this is 35. Right? That number of wins is going to equate to a certain amount of salary expenditure on the team. We're somewhat simplifying it here because obviously spending money on your coach could help increase the number of expected wins. But here we're thinking about if we were just to analyze the relationship between wins, expected wins, and just player talent, right? There are going to be some other things that factor in, but here we're just thinking about if we could just analyze the relationship between the number of wins and player talent, we could equate each number of wins from player talent to a certain dollar amount, right? So maybe in order to kind of get these 40 wins, the team had to spend, I don't know, $80 million. And the small market team to get 35 wins, maybe they were spending, I don't know, 70 million, right? What's a salary cap that I could propose, right, that would improve competitive balance? Well, let's say I propose a salary cap at 90 million. What's that going to do? Well, if I tell teams, you know, there's a certain number of wins that you could get by spending 90 million, and we don't want you to go past that point. Well, if both teams are profit maximizing here, that's going to have no effect, right? I set that way too high. It's like if every team in the league is spending under $100 million, and I say, okay, you can't spend more than 200 million. Okay, right? We aren't. You know, we don't have, nothing changes. So an effective salary cap would have to be something below this large market team's profit maximizing point, right? Something below 80 million. So I could like think of, you know, maybe there's something like right here I could set at like 75. That, you know, the small market teams are unaffected, but the large market teams kind of are forced to spend a little bit less money on their players and see a slight reduction in the number of wins. Now, what's one thing that could be, this is kind of a weird one to think about, but I think it'll help us think about salary caps a little bit more. What if I set the salary cap here at 60 million? What's going to happen? What can I almost effectively do if I set a salary cap low enough? Yeah. Yeah, I can essentially force teams to spend the same amount of money. And so, like, really the expectation is they're all going to be about the same level of quality, right? Because they're all spending the exact same amount of money on their players. If they're doing so in an optimal way, right, then we're going to end up with teams that, you know, the competitive balance is really, really good. But also, I've reduced the quality of play in the teams, right? So if I reduce the quality in the teams enough, well, maybe I see a shift in demand in subsequent years from that, right? So yeah, I want to try to set one where I can impact these higher quality, these large market teams, but I don't want to like force it too low to where I'm forcing small market teams to kind of spend less money as well. Now, some other things we might have to think about in these scenarios is for the large market teams, usually is not a big impact in terms of setting kind of salary caps. But let's say I thought small market teams, how do I do this? Yeah, so let's say that instead, I'll try to draw this green as the second scenario, that instead, small market teams are win maximizing under this scenario, right? But the league looks at this and says, well, I don't, you know, for whatever reason, they look at the number of wins, say, well, the small market teams just, they spent their money well. They got lucky this year. They ended up winning a high number of games, but, you know, they really are still kind of profit maximizing, right? We think they're still profit maximizing. They just so happen that this year they had some additional success. but they incorrectly do so. I don't know why they would do this. I'm using this to it's kind of a weird scenario just to prove a point. If I try to set a salary cap here, and I look at this and say, well, I think the large market, sorry, I said a salary cap, a salary minimum, right? Because I look at this and say, I think that my large market teams are just being lazy. They've got, I know they face a higher demand curve. They must be kind of doing something where they're not spending as much money. Maybe they're not even profit maximizing. I don't know. They're not spending enough money on their salaries, and they're getting this low number of wins. So I'm going to set a salary minimum, and I maybe do it somewhere out here, right? Actually, we could just think about it. Maybe I set it at that same 90 million. So I force teams to spend more money. Well, I can do that to the large market team, right? They'll if it's a requirement, they'll spend the additional money to meet this salary minimum. What happens to the small market team, though? Yeah, basically I drive them out of the league, right? Profits were 0 at this point, so if they get forced out to here, well, now profits are negative. I can't exist in the long run. Right? So anytime we have like a really close kind of, if we had something like this, yeah, we can always impact that large market team with a salary minimum, but we can't set it too high. Otherwise, we'll drive the small market teams out of the league. Right? So that's another good thing to be able to understand about setting these salary maximums and then these salary minimums. Any questions on that? Huh?
You got a question on Zoom?
Oh, thank you. I didn't check that yet. If you have a binding salary cap for both teams, do they target the same number of wins? Yeah, so I kind of said that earlier. If I could put it like a salary cap all the way down here, yeah, I mean, you could tell teams they can only spend $1 million total on their player salaries. Well, what's going to happen? You're just going to have a lot of like not very good teams, right? Or, right, the demand for labor is going to go way down. They're going to spend, pay players a whole lot less, right? If those, players don't have any outside options, like there's not another competing league. Now, would that be done in practice? No, it doesn't make any sense. I mean, well, at a certain point, once I get to this point, if I could get them both to target the same number of wins, why would I make them spend any less, right? That way I could keep quality as high as possible while still getting like perfect competitive balance. But yeah, you could set one that's binding for both. Could you set a, let me think. Could I set a minimum that's binding for both? Yeah, so if you think about, if I was to set something maybe right at this point where profits were 0 for a small market team, I could say this is the minimum you can spend on your salaries, and both teams would increase how much they spend. It's just that I'd have to be very careful not to set it past that point. So I could have a binding salary minimum for both teams as well. It just gets a little dicey about, I want to make sure I'm not going to drive small market teams out of my league. Any questions on this before we keep moving? Thank you for catching that for me, by the way. All right, so something that might be a little bit related to this, that would be a good thing to know, wink, wink, for the exam, is how to think about, instead of salary caps and salary minimums, how do we think about luxury taxes? Right? So luxury taxes were essentially, there's going to be we're thinking about the win market here. And let's draw first. We'll draw on this demand curve and kind of this marginal revenue curve. So if we could even simplify this to a constant marginal cost, right? So let's say marginal costs are constant. Okay. But then at a certain point, right, there's going to be a certain number of wins. We'll say it's right here, right? Where in order to get that number of wins, I had to spend a certain amount on my player salaries that is exactly meeting the luxury tax limit, right? So let's say after $100 million, that teams have to start paying a luxury tax. So whatever this number of wins is, that kind of equates to where I'm spending $100 million on my team. If I want to win any additional games past that point, I'm going to have to start paying a luxury tax for every dollar I spend past 100 million. And so, maybe initially it's only like for every dollar I spend, it's an additional 50 cents. So now any dollar spent past this point isn't only going to cost me, you can think about like the marginal cost here, each one was like $1. You can kind of think about it as for every dollar I was spending $1. Now for every dollar I spend on salaries, I'm going to have to also pay this 50 cents tax. So for every dollar I want to go over, it's almost like, and this isn't a perfect way to think about it, but I'm just I'm going to cross this off in a second, but we kind of think about it as we've seen a jump in the marginal costs, right? Now every additional dollar I spend costs me not just $1, but $1.50, right? It's a 50 cents tax. So it's almost like we'd end up with these marginal costs, and I think the MBA was the one where every $5 million would like cause another jump in that marginal cost curve. So you can kind of see here, where does marginal, here's marginal cost. It's kind of hard to map this out. So where does my marginal cost curve hit my marginal revenue curve? Well, it's going to be at a number of wins that's out here, where, yeah, I'm spending, right, to get to that number of wins, I'm going to be spending more than that luxury tax cap of 100 million, but my marginal revenue curve is high enough to kind of warrant that, right? If my marginal revenue curve and demand curve were way down here, well, now the optimal number of wins is going to be much, much lower, right? And so we can kind of think about there's probably some differences between small and large market teams there. But really the easiest way to think about it, if you're dealing with a luxury tax kind of problem or thinking about the luxury tax, you can just think about it as usually we have a supply curve, taxes push it kind of out into the left or kind of push it upwards, right? So if I'm keeping marginal cost constant, it makes it a little bit easier where that tax is just a shift up, right? Or kind of like, just like when we had a normal kind of looking supply curve, it was going to be this shift up. Okay? So I would think about it this way. If you really wanted to, we could start to model where, okay, maybe marginal cost is increasing initially. Then we hit that luxury tax amount. Now the jump is like this, right? Or maybe the jump is, we could think about it with an upward sloping marginal cost or supply curve as well. But for any understanding that you would need for any problem, keeping marginal costs simplified and kind of constant where they're horizontal lines, that's fine as well. And then your tax increases at a different number of wins is just like a movement up in that horizontal line. Any questions on that? Okay. If there's anything else I want to say about that, I think that should cover it. So anybody else have any questions like related to the exam or? Okay, so like I said, I'll be open kind of tomorrow morning all the way to the end of Sunday. Thursday, hopefully you'll have started kind of reviewing and looking at these midterm problems, but also the homeworks, the answer keys. So Thursday, if you have any questions, like bring those or ask them on Zoom or ask them in person. I want to go through problems that you guys have questions on, right? That'll be the most effective use of our time. Right, no new material or anything. So there's no online quizzes this week. We're just kind of doing some review for this exam. Making sure we have a good understanding of where we're at in the principles that we've covered up to this point. Also, I don't have anything else at this point until you turn in these homework assignments, which I'll probably hold off a little bit on grading those and grade those in the exam kind of at the same time. Only because I've sent out a few, but I want to start really churning out, make sure by the time that first exam is turned in, I want to try to have everybody's data set sent to them. So I've got a lot of them half baked, and I should be sending those out. And I'll send you whatever I have by the end of this, end of Sunday night. So even if I don't get you your perfect data set right away, I'm going to be getting you some kind of data for your project to start working with, right? And if I know that I can kind of add some things in, I'll mention that when I email you. But I might be sending you kind of a, not the perfect data set initially, but something that you can start to get an idea about what you could do and what the variables look like. Okay? But you can definitely start on the literature review section, kind of the economic principles section. And I would suggest kind of starting on that project soon, especially once you have a good idea of what your data set's going to look like. Okay? Any other questions for me before we get out of here? We'll end a little bit early today, but we'll have Thursday to cover material. So I would suggest hold off, maybe if your schedule allows it, to take that exam after we go through some more stuff on Thursday, just to be a little bit more prepared. Okay? All right, if there's no more questions for me, we'll end it there, and I'll see you guys on Thursday. Okay?